Good morning. This is going to be page 22 of your notes. We're doing 1.3b, dividing functions and domain restrictions. Okay, so recap, most of the functions we have studied in Algebra 1 and Algebra 2 are defined for all real numbers, right? So that means that their domain goes from negative infinity to positive infinity, okay? Some functions, however, are not defined as real numbers and thus are evaluated over a restricted domain. The first one we're going to talk about that we talked about during our parent functions is the square root function. And the square root function is f of x equals the square root of x. And it's restricted because we cannot have negative numbers underneath the square root. Okay. So when we are evaluating this, we know that x has to be greater than or equal to 0, meaning that it has to be positive. So that's what creates our domain restriction. Okay, so then we have the rational function, and the domain of the rational function is also restricted. And that's because the denominator cannot equal 0. So we know that x cannot equal 0. Okay, so here it says we have 3x minus 6 and x minus 2 as our two functions, and we're going to find f divided by g in its domain. So we have f of x divided by g of x, which equals 3x minus 6 divided by x minus 2. Okay, so this is what it would be before we reduce or anything. So this is where we're at. So this is simply setting up the division. Now there's a couple things that we're going to do before saying we're done with the division. We're going to analyze the domain. So to analyze the domain, we're going to use the denominator. And reason I said we use the denominator because our denominator cannot equal 0. So we take the denominator, so we have x minus 2, and make it not equal to 0. So we're going to add 2, so we know that x cannot equal 2. That's our domain restriction. So we know that it's all real numbers, but x cannot equal 2. So we have all reals, but x cannot equal 2. That's our domain. Okay. The second thing we're going to do is see if anything can be factored. So remember, factor is when you're looking for common numbers that you can evenly divide out of the terms. So our greatest common factor. So if we look here, we have 3x minus 6. Well, 3x minus 6, between this term and that term, their common factor is 3. So that means I can divide each one of these by 3. So when I divide 3x divided by 3, okay, so when you're factoring, you're taking the common factor out. So it's like the kid is moving out the house, but it's still part of the family. It doesn't just disappear. So we're left with x minus 2, and then the denominator we have x minus 2. After you factor, then you're going to eliminate if possible. And eliminate just means to divide, and anything divided by itself is 1. So we have x minus 2 in the numerator and x minus 2 in the denominator, so they are eliminated. So that leaves us with just 3. So our final answer is 3. So the f divided by g equals 3, and the domain restriction was all real numbers, but x cannot equal 2. Okay, let's try it again. So here we have f of x equals x squared minus 16, and g of x equals x plus 4, and we want to find f divided by b. What we're going to do is set it up. So we have x squared minus 16 divided by x plus 4. Okay, now setup is there, so we're going to find our domain restriction. So remember, it depends on our denominator. So x plus 4 cannot equal 0. We're going to subtract 4, and we get that x cannot equal negative 4. So we know that it's all real numbers, but x cannot equal 4. All right. Step 2 is to factor. Now this time we're factoring by a different rule. It's not GCF here. We're factoring by difference of two squares. So difference of two squares means when you have two perfect squares being subtracted, they factor out to become the square root of a. So you a minus b times a plus. So in this case, we have x squared minus 16. So to find our a and our b, essentially all we're doing is taking the square root of the first term and the square root of the second term. The square root of x squared is x. The square root of 16 is 4. So it ends up being x minus 4. And if I have the subtraction, I also have to have the addition all over plus 4. Okay? And then our last step is to eliminate. Okay? So when we eliminate, I wrote a b over 4. So what does the numerator and denominator have in common? The numerator and denominator both have x plus 4 in common. So that gets to be eliminated. And what you're left with is your answer. So after we eliminate, we're left with x minus 4. So our answer is x minus 4. And our domain restriction is all real numbers, but x cannot equal negative 4. All right, so let's do it again. So together, we're going to set up. So we have f divided by g. Here's our f, here's our g. So we have x squared minus 25 divided by x plus 5. Okay. So step 1 is where we find our domain restriction, and that's based off our denominator. So we have x plus 5 denominator. So we have x plus 5 cannot equal 0. And we're going to subtract 5 from both sides. And we're left with x cannot equal negative 5. So we know it's all real numbers, but x cannot equal negative 5. Okay. Step 2 is to factor. And again, we have difference of two squares. A squared minus b squared. So when I factor this, taking the square root of this term and the square root of that term. And that leaves me with x minus 5 times x plus. And step 3 is to eliminate. So when we eliminate x plus 5, and we're left with x minus 5. So our domain and our answer, x minus 5. Okay, I want you to give this a try. So pause and then come back and check yourself. All right, so I hope you paused. So the first thing you should have done was set it up. So you get x squared minus 9 divided by x minus 3. And then your domain restriction is based off of your denominator. So we have x minus 3 cannot equal 0. So we add 3 to both sides. And we get x equals 3. And x cannot equal 3. So we know it's all real numbers. But x cannot equal 3. That's our domain. 2, we're going to factor if we can. And we can. And we're factoring by a squared minus b squared. So we're taking the square root of x squared and the square root of 9. And that gives us x minus 3 times x plus 3. And we are left with x minus 3 in the denominator. Step 3 is to eliminate. And we can eliminate x minus 3's. And that leaves us with x plus 3 as our final answer. If you did not get this, do you see where you may have made a mistake? Awesome. All right, so pause again and give this a shot. Okay, so let's see. So your setup should have been f divided by g. So you have x squared minus 4 divided by x minus 2. Step 1 is your domain restriction. So we have x minus 2 cannot equal 0. And add 2 to both sides. So we know that x cannot equal 2. So it's all real numbers. But x cannot equal 2 is our domain. And then 2, you're going to factor. And again, we're factoring by difference of two squares. So a squared minus b squared. Square root of x squared, square root of 4. And that gives us x minus 2. And we have to have x plus 2. Our denominator is x minus 2. Step 3 is to eliminate. So we're going to eliminate. And we have x minus 2 in the numerator, x minus 2 in the denominator. And that leaves us with just x plus 2 as our solution. All right, there's a couple practice for you to do on Canvas. Hopefully you guys feel confident and are able to complete this.